Hello, my name is Michal Bock. I work as a Go developer at Utility Warehouse, and I'll be talking about managing Go routines in Go. So let's go. Let's start some Go routines. So here we have a simple program that has one for loop which performs 10 iterations, and on each iteration it starts a new Go routine and prints this is job and the number of the job it's executing. So if we run this, we'll see that nothing is going on. So as a newcomer to the language, you might be asking yourself, what is going on? Just put on this face and be like, this is a bit weird, because you might expect that this will print out numbers from 0 to 9 in some sort of random order. Then if you go and look at the Go spec, you might find the answer. If you look into this bit, there's a link to the Go spec. And I'll just read it out loud. So this says, program execution begins by initializing the main package and then invoking the function main. When that function invocation returns, the program exits. And the important bit here is the bit highlighted in bold. It does not wait for other non-main Go routines to complete. So what happened in our first program is that our main function started a bunch of Go routines and then finished. And so then the program didn't wait for all the non-main Go routines to finish, and so it exited, so we didn't see any output printed. So this means we need, if we want to ensure that all of the Go routines terminate, we'll need to make sure that that's the case ourselves. As with lots of things with Go, there is something in the standard library that helps you to do this for you. There's a package. There's a primitive called Wak Group, which lives in the syn package. It's essentially a thread-safe counter, which has 3 methods on it. One add, which increases the value of the counter. One done, which decreases it by 1. And then wait, which is a special function, which waits for the value of the counter to go to 0 and blocks until that's the case. So to fix our small program, we just create the Wak Group. And before starting every Go routine, we add 1 to the counter. And then in a deferred statement, we call done on the Wak Group. This is to ensure that, okay, here we are just printing one line, but in other scenarios, you can imagine the function might panic, and calling the defer statement will ensure that the counter gets decreased no matter what, and so that the call to wait won't block indefinitely, and so won't cause a deadlock. So if we, I want to do this. It's tricky. If we run this, yeah, we got 10 outputs, but there's a peculiar thing. There's a suspicious number of number 10 appearing. What is happening here is that we have a data race. So if you tried running this program with the race detection enabled, the Go would tell you that there is a race, and the race is on the variable I. And this is because we are inlining a function definition here, which refers to the variable I, which is reused on each iteration of the loop. So yeah, well, by the time these Go routines gets executed, the main loop already terminated, and the value of I was already 10. So that's why we are seeing this output. So to fix this, we can just pass in I as an argument. I call it job ID. And why this works is it's because arguments for functions we are calling the Go routine are evaluated in the current Go routine. So when Go executes this program, when we call Go, it evaluates the value of I, which at the first iteration is 0. So it puts away this function we're going to execute and value 0 for some part of the process to execute. And then on the next iteration, it does it the same with value 1. So if we run this, we'll see that we get the output you would expect to begin with. But what about the errors? Like, this was a very simple example. We kind of executed a simple job, which was a function that takes no arguments and returns no results. But in a more realistic scenario, things go wrong, and we would want to handle errors. So a more realistic job, I called it a real job, would be to take maybe no arguments, but return an error at least. So let's define a job that can fail. This is just a simple function that takes its job ID, generates a random integer value between 0 and 12, and if that value is equal to the job ID, then it returns an error because it freaks out because random number shouldn't be equal to my job ID. And then it prints, otherwise it prints that it's done and returns a nil error. To collect all the errors, we can make use of buffered channels. So we are creating a buffered channel with a capacity 10, which equals to the number of Goroutine we are using. So the rest is as before, so we add to the Wak Group 1 and then call the done in the deferred statement. But then we check for the error here, and if we encounter one, we just write it to the channel. This will never block because the channel is buffered, and the number of Goroutines equals to the capacity of the channel, so there will always be space to put the error in the channel. After we started all our Goroutines, we call the wait on the Wak Group, and then here we are using another property of buffered channels, which is that you can always read all the values that were already written to it prior to it being closing. So even closing it here, we can still iterate over all the errors we encounter. So if we run this simple program, we can see we got two errors, everything went fine. What if we wanted to handle termination? So the standard way of doing it is to use context. Context is a built-in primitive. It's an interface. It has a whole bunch of methods, and it's used all over the place. But for this talk, the relevant method is done, which just returns a channel from which you can read, and this channel gets closed when the context gets cancelled. And we usually cancel the context when we no longer care about the result, or we want to signal to the function we are calling that we don't want it to continue doing whatever it's doing. This is like just a simple wrapper which I like to use, which wraps the background context and returns one that gets cancelled when the program receives a SIGINT signal or SIGTERM signal. So that means if I run a program on my command line and press Ctrl+C, this context gets cancelled, and I can assure clear termination. So if we want to job with a context, then we just take the one we had before, so the end is same before, and then we have this select statement, which essentially performs a random sleep that can be interrupted by context cancellation. So that's why we are listening on the done channel here. If this branch returns, that means the context was cancelled. So we have this print statement that says so, and then return a nil error. Otherwise, we have this other branch which calls time.after, which also returns a channel. And what this does, you pass the after function at duration. Here I'm passing a random duration, and after this duration after this duration, current time will be written to the channel returned. So then this select statement will execute, and we get here, and then we can do our usual business of doing checking if the random number is equal to our job ID. So now putting it all together, it's pretty much the same, apart from us creating the context here and then calling the job with the context. And yeah, it works as expected. Now it's a bit slower because we are sleeping during executing. But this looks like this is a lot of effort, like creating a channel and managing this all on your own. I mean, I'm a lazy person. I don't like to recreate this type of stuff. So you might be wondering, is there something which you can use that will make your life easier? And of course there is. It's Go, so people do all sorts of stuff. There is Error Group, which lives in the experimental package. And it has even simpler interface than the Wak Group. It only exposes two functions. One is called Go, one is wait. Go starts the function you provide in a new Goroutine. So, but it takes a function that's, if you go back a couple of slides, that's my real job. Which takes no arguments and returns an error. By the way, here I am avoiding the problem with having the race condition on variable I by creating a copy of the variable which is local to the current execution of the loop. So that's why all this works. And then we call wait, which does the same as on the Wak Group. It just blocks until all Goroutines started in the group terminate. And in this case, it returns an error. It returns the first error we encounter from any of these functions. We are initializing the error group with a context, and we get another context back. This context gets cancelled as soon as any of the functions started here returns an error. It also gets cancelled when wait returns for the first time. So that means we can't reuse this context. So after after one iteration, so we'd have to create a new one if you wanted to run it multiple times. So if you try running this, we can see that, this is a good example. So we have we see that job 5 failed, and a bunch of jobs succeeded, a bunch of jobs terminated on context cancellation. So all works as you would expect. But what if we wanted to keep the behavior we had with the error channel, and so that we can still have all errors with a counter? That would be like more convenient for our use case. So you might hope that the error group would have a signature that gives you a slice of errors instead of just the first one. So for that, I would just like to show some code. So here is the implementation of error group. It's very simple. It uses a wait group under the hood. And what it does in the Go call is what we did before, which is it adds one for each function you start. It adds one to the wait group, and then calls done in the deferred statement, and it checks an error, and then uses this error once, which is a sync.once primitive, which only performs the function you give it once on the first call. So on the first call to the do function will actually succeed. That's why we don't have a race on the error field, and then we cancel the context once we encounter the first error. And that's about it. And then the wait just calls wait on the wait group, and it cancels the context and returns an error. So that's about it. So if we wanted to change the behavior, we can just substitute the single error for a slice of errors, and instead of using the sync.once primitive, we can use a mutex. And that's exactly what I've done here. So substituted these two, then wait is pretty simple, so we just return the slice of errors, and instead of calling the sync.once, we just acquire the mutex, append to the slice, unlock, and continue with the business. So it's pretty simple stuff. So what I was trying to say here is sometimes some of these things are pretty simple, and it's useful to look at the implementation and maybe try to figure out if we can just copy it, adjust it slightly. That will make our lives much more easier, or maybe just make a wrapper around it or simulate the strategy. If you want like some other alternatives which we made and found useful, we have a run group primitive which behaves like error group, but it forces you to use context, because you don't have to use the context if you don't need it. But it's in this case in run group cancels the context as soon as any of the Goroutines starting in the group terminates. So this is useful for running pipelines if you want to terminate cleanly in some conditions. So let's say if you have a pipeline and you need all the pieces to work to be running in order for normal execution, and then if one of them returns, then you can just initiate a clean shutdown. And then there's like another one called Go group, which the call to wait only blocks until the context gets cancelled, and this is kind of useful in bidirectional gRPC streaming. I can talk about it later. I'll meet you at a pub. But if any of you have any like other variants to error group, I'll be happy to hear about those later on, because I quite enjoy this subject, as you might be able to tell. If you found this any interesting, then I wrote a blog post which you can go to through this link. It has like links to the Go playground which you can click on and try this stuff. And if you're interested in UW, then you can just click on this link and go look at the carriers page. And that's it, I guess.